The year is 1942. The Battle of the Atlantic is being lost. German U-boats are sinking Allied ships faster than they can be built. Winston Churchill is desperate for a solution when a most improbable proposal lands on his desk: build an unsinkable aircraft carrier from ice. This wasn't a joke or a fantasy. It was Project Habakkuk, one of World War II's most bizarre and ambitious secret projects. The brain behind this frozen madness was Geoffrey Pike, an eccentric inventor and journalist who had already impressed Churchill with earlier unconventional ideas. Pike's concept was radical: create giant aircraft carriers from a material he called picrete, a mixture of 14% wood pulp and 86% ice. This composite material, he claimed, would be stronger than concrete, unsinkable, and could be repaired simply by adding more water. The military problem was real. Mid-Atlantic air cover was virtually non-existent in 1942. Aircraft couldn't reach the Central Atlantic from either Britain or North America, creating a black hole where U-boats operated with impunity. Conventional aircraft carriers were too vulnerable to U-boats and too expensive to risk in these waters. Pike's solution: a 2,000-foot-long, 300-foot-wide floating ice island that could carry 200 aircraft and sail anywhere in the Atlantic. Churchill, always drawn to unconventional thinking, gave the project his personal approval. In December 1942, he wrote, "The advantages of a floating island or islands, if only used as refueling stations for aircraft, are so dazzling that they do not need to be stressed." Project Habakkuk was born, named after a biblical prophet, because, as Pike joked, his writing was so obscure that nobody could understand what he was talking about. The first tests began in early 1943 at the top-secret HMS Habakkuk Research Facility, actually a frozen meat storage locker under Smithfield Market in London. Scientists mixed sawdust with water, froze it, and began testing. The results were surprisingly promising. Picrete was indeed incredibly strong, bullet-resistant, slow-melting, and with the buoyancy of wood. A .303 bullet fired into pure ice would shatter it. Fired into picrete, it would embed just a few inches. By March 1943, the project had moved to Patricia Lake in Jasper, Canada, for larger-scale experiments. Here, scientists built a 60-foot prototype that actually floated. They installed a 1-horsepower motor, dubbed HMS Habakkuk in official documents, and proved the concept could work. The prototype remained frozen throughout the summer of 1943, protected by an insulated blanket and a refrigeration system. The planned full-scale Habakkuk was mind-boggling in its dimensions. At 2,000 feet long, it would have been twice the length of the largest aircraft carriers of its day. But the engineering challenges were monumental. The refrigeration system alone would require 26 electricity substations. The ship would need 40 electric motors driving outboard propellers. The construction would consume an estimated 300,000 tons of wood pulp and 25,000 tons of fiberboard insulation. The cost was estimated at £10 million, about £500 million today. As 1943 progressed, two developments began to undermine Project Habakkuk. First, the Allies were winning the Battle of the Atlantic through conventional means: more escort carriers, better radar, improved convoy tactics. Second, Portugal finally agreed to let the Allies use air bases in the Azores, providing the mid-Atlantic air cover they desperately needed. By December 1943, the project was in trouble. The estimated construction time had grown to 8 years. The cost kept escalating, and military priorities were shifting as D-Day planning consumed resources. The stage was set for Project Habakkuk's dramatic but quiet demise. As 1943 drew to a close, Project Habakkuk faced its ultimate test, not of engineering, but of military necessity. The very problem it was designed to solve was being addressed by more conventional means, leaving the giant ice ship looking increasingly like a solution in search of a problem. What followed was one of the quietest cancellations of a major wartime project, but not before one last dramatic demonstration that nearly killed the British admiral. In late 1943, Lord Louis Mountbatten, Chief of Combined Operations and a Habakkuk supporter, decided to stage a dramatic demonstration for Allied military leaders. During a strategy meeting in Quebec, he produced two blocks, one of pure ice, one of pykrete. He placed them side by side and invited the most skeptical attendee, American Admiral Ernest King, to shoot them with his service revolver. The first shot into the ice block shattered it spectacularly, as expected. The second shot into the pykrete block produced a very different result. The bullet embedded itself barely an inch deep, and the block remained intact. According to eyewitness accounts, a fragment of the bullet or ice then ricocheted and narrowly missed King, adding unexpected drama to the scientific demonstration. The point was made. Pykrete was remarkably bullet-resistant. Despite this impressive demonstration, practical problems multiplied. The refrigeration technology needed to keep a 2-million-ton ice ship from melting in the Atlantic summer didn't exist. Engineers calculated that the cooling system would require the entire output of several power stations. The ship's propulsion was another nightmare. Early estimates suggested it would need so many propellers that it would essentially push a wall of water before it. Then came the most ironic problem. Pykrete flowed. Like glaciers, the material deformed under pressure. A full-scale Habakkuk would gradually sag in the middle unless constantly reshaped. This plastic flow meant the ship would require a small army of workers, constantly shaving and reshaping its hull. A practical impossibility on an active warship. The final blow came from changing war circumstances. By early 1944, the Battle of the Atlantic was turning decisively in the Allies' favor. New technologies like centimetric radar, hedgehog mortar, and improved sonar were making U-boats vulnerable. Long-range aircraft like the B-24 Liberator could now cover the entire Atlantic. Most importantly, the Allies had captured enough French ports to provide air cover across the critical mid-Atlantic gap. In December 1943, the combined chiefs of staff quietly recommended terminating Project Habakkuk. The official reasons cited were excessive cost, estimated at 100 conventional aircraft carriers, technical uncertainties, and most damningly, the vessel would be vulnerable to torpedo attack despite its size. The last point was particularly ironic. The unsinkable ship was deemed sinkable after all. The prototype in Patricia Lake was allowed to melt naturally. It took 3 summers to completely disappear, its refrigeration system having been turned off in 1944. Locals reported seeing strange shapes in the lake for years afterward, as the wooden skeleton gradually decomposed. Today, a plaque marks the site, and divers can still visit the remains of the refrigeration system on the lake bottom. Geoffrey Pike, the brilliant but temperamental inventor, took the cancellation hard. He had invested his entire being in Habakkuk and saw its termination as personal failure. He would work on other projects, but never again achieve the same level of influence. He died by suicide in 1948, a tragic end for one of war's most creative minds. The legacy of Project Habakkuk extends beyond its failure. The research into pykrete contributed to later studies of composite materials. The concept of mobile floating bases would resurface during the Cold War, and the project demonstrated both the Allies' willingness to consider even the most outrageous ideas and their practical ability to kill projects that no longer made military sense. Perhaps the most enduring lesson of Habakkuk is about innovation itself. In desperate times, even ideas that seem insane deserve consideration. The project consumed 10 million pounds, about 500 million pounds today, and hundreds of man-years. But it also kept pressure on conventional solutions and demonstrated creative problem-solving at the highest levels. Today, the story of Project Habakkuk serves as a reminder that sometimes the most ambitious dreams do and fail because they are impossible, but because the world changes around them. It stands as a monument to human ingenuity and to the practical realities that even the most brilliant ideas must eventually face. What's your take on such ambitious secret projects? Should militaries continue funding crazy ideas, even when conventional solutions are working? Share your thoughts in the comments, and don't miss our next video about Hitler's mysterious Nazi Bell weapon.